In this section, section 8.1.3, we'll be looking at linear programming problems that have infinitely many optimal solutions. All right, so our goal is to understand when a linear programming problem has infinitely many solutions, and then to write down all of its optimal solutions. All right, so let's start with an example. This example will take us through what we have to do, and then we'll recap afterwards. All right, so we have a company, the Mirabelle Company, which builds two types of kayaks. There is the relaxed kayaks and the adventure kayaks. Each type requires a different amount of carbon fiber, fiberglass, and a different number of man-hours. These are given in the following table. So assume that this company orders 400 square meters of carbon fiber, 200 square meters of fiberglass each week. Also assume that it has access to 1,200 man-hours per week. And we know how much profit each gives, so assume also that each relaxed kayaks bring the company $300 of profit, while an adventure kayaks brings in $400. All right, so we're asked to turn this problem into a linear programming problem in order to find the number of each types of kayak that the Mirabelle Company should build to maximize its profit. All right, so let's start by defining our variables. My first variable will be the number of relaxed kayak that the company should build. And y is the number of adventure kayaks that it should build. We want to maximize the profit, and so the objective function, the function that we're trying to maximize, would be, well, we always call it P, but let's see. We're getting 400 for each adventures and 300 for each relax, so it's 300 times the number of relax, 400 times the number of adventure. All right, now we need the constraints. We need one constraint for each resource. And so first resource that we'll look at carbon fiber. All right, so for the carbon fiber, we have 15 and 20, 15 for each relax and 20 for each adventure. That's how much we'd be using. And then the company has 400 of that, in a week. Fiberglass. All right, for the fiberglass, I am using 10 for each relax, 5 for each adventure, and I have 200 in total. So it's 10x plus 5y is less or equal to 200. And then I have man hours. All right, so let's put those in green. Man hours are here. Those are for 10 hours. It's probably a good idea to go with man hours for 10. I need 1x plus 8y, and that has to be less or equal, this is the number in total, so 120, because it's in 10 hours. All right, so here is our linear programming question, and of course, x and y need to be positive. It doesn't make any sense to produce a negative number of kayaks. All right, that's for A. Now let's set up the initial tableau of the simplex method. We're going to add slack variables. So I'll have 15x plus 20y plus s1 is 400. That's going to be my first equation. So x, y, s1. I have 3 constraints, so I need 3 slack variables. First one is 15, 21, 400. Second is 10x plus 5y plus s2 is 200. So 10, 5, s2, 200. And then I have x plus 8y plus s3 is 120. So 1, 8. All right, so those are my constraints. And then I have to have one equation for the profit function. So from p equals 300 x plus 400 y, I get that p minus 300 x minus 400 y equals 0. So minus 300 minus 400 and then 1. All right, so here is our initial tableau. In the following videos, we'll keep on working on this example and we'll see what the reduction gives us and also what it means for the optimal solutions.